Alright, so we're going to begin this video by going over the basic area formulas, the areas of three basic shapes. As a reminder, this should follow from your last video. These are things that you should know. The area of a rectangle is base times height. Now, to keep in mind, the crucial idea is that the base and the height are perpendicular to each other so that you can have those square units, as we spoke of in the last video. The area of a square is s squared. That's because the square, the base and the height are both the same. They're each s. And since a square is just a rectangle, we can again do base times height. So this fundamental idea is applied twice. The area of a rectangle is the same thing as the area of a square. Okay, and then last but not least, we remember that the area of a triangle is half of the base times the height, or you could say multiply the base times the height and then divide it by 2. Same thing. And so here's my triangle. And so notice here's our base, here's our height, and the base and the height must be perpendicular to each other. That is crucial. In every one of these pictures, we do in fact have a right angle, and we need a right angle. So now we're going to look at some funkier shapes, and we're going to try and bring back every new shape. We're going to try and deconstruct it and kind of turn it into a rectangle, really. Okay, cool, let's go for it. Alright, so now we're going to develop the formula for the area of a parallelogram. So here will be my parallelogram. Okay. So just as a reminder, we know in a parallelogram, we know that opposite sides are parallel and opposite sides are congruent. Okay, so what we're going to do, again, we're going to really try and bring everything back to the area of a rectangle, which is base times height. What we're going to do here is we're going to drop an altitude. That looks horrible, but let's go with it. We're going to drop an altitude right here, and really we're going to turn this parallelogram into a rectangle by taking this piece right here. We're going to cut along that altitude, and we're going to kind of bring this piece and fit it right in over here. And what's nice is this right angle that was right here from our altitude is going to get placed right there. Same side, interior angles are supplementary, so we do in fact have a straight line here. So now this portion is gone, and we have effectively turned our parallelogram into a rectangle. And so if you have to say, well, what would be the area of this parallelogram? Well, originally we had this portion right here and this portion right here. This would be the base of our parallelogram. And we just kind of shifted this piece and moved it right over here. But it's still the exact same piece. So what's cool is the base of this rectangle is actually the base of this parallelogram. So the area of this rectangle is going to be base. And then remember we cut along an altitude here. That altitude is, another word for that is the height. So this height of the rectangle is the height of the parallelogram. So what's interesting is we turned a parallelogram into a rectangle. They do in fact have the same area, and so they have the same area equation. The area of a parallelogram is in fact base times height as well. And it's because we can turn a parallelogram into a rectangle, and they both still have the same base and the same height. So area of a rectangle is base times height, bada bing, bada bang, bada boom. Alright, so now this is going to be kind of cool. We're going to take a trapezoid, and we know, here's how my trapezoid's going to look. It's not going to be isosceles, just any old trapezoid. We know that the bases are parallel in a trapezoid. The legs are not necessarily congruent. And we do know that the upper and lower base angles are supplementary. because of properties of parallel lines. So those two angles are supplementary, those two angles are supplementary. Notice how those two are not congruent to those two because we do not have an isosceles trapezoid. So now what I'm going to do is I'm going to duplicate our trapezoid. And just remember how we found the area of our parallelogram. We turned it into a rectangle. What we're going to do with this trapezoid is ultimately turn it into a rectangle, basically. All right, so let's select the trapezoid. We're going to duplicate it, move it down here, and now what we're going to do is we're going to rotate it. So now I'm going to take this, and let's see how it goes. I'm going to fit it right here. And now bear in mind, this is not perfect. Oh, but do you see how it keeps rotating? Alright, ladies and gentlemen, that's the best I can do. So thank you for bearing with me. But so basically we just took the exact same trapezoid, we rotated a little bit, and then if you look at this shape, what did we make? Well, we made a big parallelogram. We took the trapezoid we were trying to find the area of, and we duplicated it. And so now what's cool is the original trapezoid had two separate bases. We call them base 1 and base 2, and it had a height. Well, now let's see our rotated trapezoid. The base 2 is now down here, base 1 is up here, and the height is still maintained. What's pretty cool is if I said, hey, what's the area of this monster parallelogram? You could say, well, the area of a parallelogram is base times height. So what's the base of this monstrous parallelogram? Well, it's b1 plus b2. And I'm going to call this A double, because this is for the area of like this double trapezoid. Remember, we took our trapezoid and we duplicated it. So, and remember that the area of a parallelogram is base, is base times height. The height we drew in the altitude, there was our height. So now that's the area of our double trapezoid. So really the area just of a normal trapezoid, if you think about it, we wouldn't want to have this double area. So what we can do, since we duplicated the trapezoids to fit them together, we'll just take half of that area, and that will be the area of one of our trapezoids. So now we can just take half of it. The way we commonly write that is we could just take half of the bases and times it by the height. Another way we could do it is we could do b1, b2 times the height. Everything take half. Just show you another way we could write it. We could even say half of base 1 plus base 2 times the height. Okay, and you'll learn more about this in class, but this thing right here, this b1 plus b2 take half, that looks like an average or a midpoint, or what we would call this is the median. The average of the area of a trapezoid is the median. This portion right here, we call it the median. It's going to be the median times the height. So you have the two bases, and you kind of average them, and it's almost like you're rectangulifying this trapezoid. The average of your bases times your heights, or the median times the height. And we'll get further into this, but remember, we're just exploring formulas for now. All right, so cool. The area of a trapezoid, we turned it into a parallelogram. We know the area of a parallelogram is base times height. And voila. And now for the area of a kite. We're going to turn a kite. Here's our kite right here. We know that we have a couple of disjoint pairs of congruent sides. Also, here's our kite. Naturally, it would make sense. You'd probably feel inclined to draw on your diagonals. Notice how the diagonals are perpendicular. And then what's really, really cool, let's actually kind of look at these diagonals a little bit. We have one diagonal like this. I'm going to call this D1. It doesn't matter if I call it D1 or D2. The other diagonal is this length, and we'll call it D2, let's say. What we're going to do is we're going to turn this kite into a rectangle. We'll move, and pause the video, see if you can figure out how to do it. We're going to push this up here, And we're going to push this up here. And then notice this green rectangle right here. If we push that piece in and push that piece in, we would be filling this entire portion right here, and we'd perfectly be making a rectangle. So now you might ask yourself, well, what's the area of that rectangle? I'm going to remake it down here. Well, we know that the length was D2. Or you could call it the base, rather, of this rectangle. Or length times width, base times height, same thing. Here's one dimension. And then now, this diagonal, remember this diagonal is bisected. It's a feature of a kite that one of the diagonals is bisected. We kind of cut our diagonal 1 in half to form this rectangle. So diagonal 1 was only half as big. And then the area of a rectangle is base times height. What's your base in this case? Your base is D2. What's your height? Perpendicular is going to be 1/2 D1. So the area of a kite is 1/2 D1. So we've got our 1/2 D1, and then times D2. Now, just to be clear here, we have our base times our height. If I multiply 1/2 D1 times D2, that's base times height. That's how I get my formula. And keep in mind, we can also say the area of a kite. You could just say it's D1 times D2, take half. Both of these formulas mean the same thing. And how did we get that formula? Again, we turned a kite into a rectangle. And then we, observed really how we how we used the diagonals to kind of morph it into a rectangle. All right, team. So last but not least, we have the area of a rhombus. So here's what's kind of cool. A rhombus. So here's my first go. You can think of a rhombus in two ways. You could say a rhombus has perpendicular diagonals. So the area of a rhombus will be treated just like the area of a kite. So that'll be diagonal 1 times diagonal 2, take half. That's pretty cool. Or a rhombus is can not only be thought of as a kite. Here's the same rhombus again. But we also know that opposite sides are parallel in a rhombus. So a rhombus is a very special parallelogram. So what we can do again is drop an altitude down. Remember, you always need a perpendicular. There's your height. This entire length is your base. And so what's the area of this rhombus? It could also be thought of like a parallelogram, and it's going to be base times height. So either formula works for a rhombus. And if you think about it, that's pretty nifty. Thank you and good night.